to William Roberts, who's going to be talking about Docker and some takeaways there. So please go ahead.
Okay, thank you. Let me pull up the slide. I'm going to run the slide directly in Teams, so hopefully this should work for everybody. Are you able to see my slides?
It looks good.
Okay. So yeah, I guess my 12 minutes starts now. So hello, my name is Will Roberts. I'm a software engineer at the University of Wisconsin-Madison. I have a lot that I want to go over today, so with regards to Docker, so let's get going. The purpose of this talk is to expose you guys to Docker concepts and spark ideas and bring attention to tools and concepts without necessarily going into the nitty gritty and the deep dives. So it's okay if you walk away and you don't understand everything. This is just to provide a gateway and hopefully excite you about some of these tools. I do have a GitHub repo that's a work in progress with this slideshow on it. Posted in the chats here too. So the intended audience for this is people who have a very basic understanding of Docker. Even if you haven't used Docker, hopefully you can walk away with some exciting new ideas and maybe an inspiration to start using Docker. If you're not familiar, Docker is an open platform for creating application images and running said applications in containers. If you're familiar with virtual machines, containers are similar but different. And the big difference is that containers run on the kernel up, so they don't have nearly as much overhead as virtual machines do. If you are familiar with virtual environments like Conda or Mamba, those simplify packaging management and deployment. Docker simplifies system and application management and deployment. And it's by far my favorite tool. I use it every day for almost everything just because it makes development, deployment so much easier. So as a basic example, you have these Docker files where you build an image from a operating system or an operating system with pre-installed software, and you can run commands and install your own software. You can copy local files from disk, and then you can build the image and run it. So this is a little bit cryptic, but I think this kind of highlights the point of, okay, I built this image and then I run it and I have the contents of this hello world, and then Python 3 is installed. So once an image is created, it is a static object. It won't change over time. And this is fantastic for production environments where you create your software and you want to give it to users and you don't want to change over time so that it doesn't break. And it's very easy to distribute it and tag images and versions and just deployment in general. Each Docker command is a layer. So if you go back, this from, this run, that copy, those are 3 layers there. And those are accessible later on. So for security issues, which I'll touch on in a few minutes, those are accessible. And they also increase the total size of the image. But there are workarounds for this. Docker, the beauty of Docker is that it can run across many systems. So if you have Docker installed on Windows, Linux, Mac, the Docker image that you pull with a few limitations will run the same, and it's easily accessible between almost any system with Docker. The limitation for that is the CPU architecture. Currently, depending on what the CPU you're running is, if it's ARM versus AMD 64, if it's not compatible with that architecture, it won't work, but a lot of images are, and you can build images that are compatible for both. I'm going to skip over a lot of this in interest of time. But containers run their own file system. So when you start a container, it's its own isolated environment. So if you create a file in there without mapping it to disk, it will go away, which is good for a lot of cases where there's unwanted resources or unwanted files that are left over. It's very easy to isolate. And Docker combines a lot of utilities. You can run in the background. You can access the running containers and run commands similar to how you would with a screen session. And then my favorite is virtual environments. So it's very easy to distribute your working environments. I'm going to skip this slide out of time. Pre-built software, and this is where it really shines for open software. You can, with one command, start a Docker container that has pre-built Jupyter notebooks with Dask and NumPy and Pandas and all these beautiful libraries we've been talking about already installed, and all of a sudden it's just running on any Mac, Windows. And a nice trick you can do with that is you can then pre-make Jupyter notebooks, build it into the image, and then your image comes with example notebooks already installed into them. You can run Java servers. So I have a server running for my friends in Docker of Minecraft. So I have a Minecraft server in a Docker container that can be deployed anywhere. Nginx web servers, Docker and Docker, MinIO, which can map local file systems to object storage for testing, databases. I mean, it's endless. If you type in Docker Hub and then some sort of software, you'll probably find compatible images. So there are a lot of Dockerfile commands, and the documentation and examples online are better than I could ever do. But as a brief just exposure, the arg command is really nice for build time in variables. So if you want to version your image, or you want to specify a Docker image to build from dynamically at build time, you can specify a Docker arg command and then pass that variable through the build stage. You can tell it to use a default user. You can set an entry point script, which will take the input that you provide to a Docker run command, and it will then pipe it into that that entry point script. You can set metadata using label. There's just so many useful ways to control your image and make it seamless for users. There are a few Docker-only Dockerfile commands that don't work with other container software, such as like Podman and Kaneko and other things, but I'm going to skip those out of time. And this is really the meat of, if you haven't used multi-stage builds, this is why I'd like to spend a couple minutes on. Multi-stage builds are a way to reduce image size, improve security, simplify your Docker deployments. So here's an example where we are pulling a Conda Forge image and building a Python environment with Xarray and Python installed, and then that is all in a packaged environment, packaged directory in the container. But there's a lot of overhead with Conda environments. So if you don't necessarily want that in production, you just want the libraries to be used for running your code or whatever you're doing, you can then specify another image in that Docker file, in this case, a very small Debian image, and you can copy over that environment directory. And then I have some code here to source it. So you need to tell the environment when it runs, hey, this is where the environment is, use it. That had some very nice results. In this exact example, it reduces the image size by 3 times. So you go from 1.2 gigabytes to 400 megabytes. The other very useful aspect of multi-stage builds is that the intermediate stages, so in that case, the first Conda image, is not cached. It's not accessible in the image. It's just thrown out. So that's really good for sensitive information like usernames and passwords. For example, if you want to download data from your AWS account and you didn't want to risk having your secret key exposed, you could use that in the intermediate stage. And the general term for that in Docker and containers, they're called secrets, but they're not necessarily secret, they're just sensitive data. So right now, the only caveat is that caching intermediate stages is a little bit clunky. So if you're worried about runtime, if you're doing a bunch of CI builds, that might be a concern. But there are workarounds. They're just not trivial. You can check the log files of the Docker commands running, so you can access a std out. The big thing with this is if you have continuous running processes, like a web server that's printing out tons of output, that can fill up your storage pretty fast, depending on how big log files are. So you can note that you can cap the size of those log files and prevent that from happening. One of the other amazing things about Docker is that when you run the containers, you can specify with just a single command line flag how much memory and CPU to use, and that's both soft and hard cap. So if you have a scalable process, again, a web server is a good example where you have all of a sudden a huge influx of requests and users, it might drive up the memory depending on what you're using. And you can put caps on that to say, I don't want to use more than 2 gigabytes on this container, and it will hard cut that off. So it's really nice to easily control CPU usage. You can also cache from containers to increase speed, all sorts of cool tools. Docker volumes are like a Docker managed file system. It essentially abstractifies away your individual machine, and it has Docker handle like the directory trees and everything. So it avoids a few problems. First of all, it helps with speed. The I/O is supposed to be faster. I don't know about in every situation, but in theory, it brags about being faster. And then secondly, it avoids certain problems with permissions. Docker networks are a way that you can create a network and the Docker containers can communicate with each other. By default, they have their own network, but you can create and join them. If you specify the host as the network, that is the same network as the system that ran the container. So that way you can access localhost on your machine, and it will access localhost on Docker container and vice versa. And you can also just cut off networks entirely. So you can just set to none, and that way you can avoid accidentally pushing data to a external database during testing. You can deploy images to a registry, so that way you can have users publicly access your made images and version your software. So in this case, I have 1.0, and it's a great way to just easily distribute your software, and anybody, as long as it's an open repository like Docker Hub, can just go pull your image and use it, and it's that easy as long as they have Docker installed. And then the last thing, the last couple things I'd like to touch on, BuildKit is a new way of building Docker images. It's currently built into Docker Desktop, but not all versions. It's a fringe, up and coming way of improving Docker. And this includes parallel builds, multi-stage caching. You can make multi-platform images. You can pass sensitive data directly without having to do a multi-stage build. There's just a lot of cool things I'd look into it. And the Docker equivalent is called BuildX. So either look up BuildKit or Docker BuildX. It has a lot of cool tools that you might be able to find useful. Non-root images are the preferred way to run Docker containers. By default, Docker runs images built as root, which has some security problems, especially on Linux. And it's a little bit clunky right now, especially when you try and mount data from disk. But this is an example where I create a user, I set the directory to the user's home, and then I say run as the user. And that will run as non-root whenever you run that container. The only problem with this is right now, some systems like Linux will mount a local directory as root inside the container. And there's no way to say mount this as non-root. And that is problematic. There are solutions, but again, it's not trivial. One way is to change some Docker daemon flags. There are workarounds using volumes or cloud storage, but again, out of interest of time, I'm going to skim over that. If you have a Docker container, you can easily deploy that to the cloud. Using Kubernetes, for example, is the big one right now, but If you have your software containerized, it is relatively easy with somebody who knows how to use cloud services to get that container and get that software running in the cloud and distribute that and scale it and have all the benefits of cloud computing. AWS, Google Cloud all have amazing starter free tier to get started with that, but that's out of scope of this. So I just wanted to mention it. There are a few extra miscellaneous commands like Docker system prune to clear your images, Docker inspect to get more information on Docker objects, Docker secrets. But again, hopefully this, I know it wasn't great in-depth explanations, but hopefully this gave you ideas of what to look into or sparked some ideas of how to get started with Docker or cool tools in Docker that you might not be using yet. So thank you to Adam and Arm for putting this together, and thank you to SSCC for letting me research Docker.
All right. Thank you, William. Do we have any questions? I guess my first question is, if you want to learn more about Docker, what sort of resources would you recommend or sites?
Honestly, just the Docker documentation. They have a really easy, quick start. I think it's pretty straightforward. Just to get started. If you have no experience with it, yeah. If you have any questions about Docker or stuff I talked about today, please feel free to email me or reach out. So.
Okay.
Great. Yeah, there's a lot of amazing resources online.
So I guess the other question I had, and since I'm not seeing any in the chat here, I've known about Docker. I haven't really looked into it a whole lot. I guess I've had trouble kind of understanding, when to go with, something like a Docker container versus, just putting your code up there, as part of a package that, has the environment kind of defined. What would you kind of recommend as pros and cons, I guess, of each way?
So the really nice thing with Docker is you get the entire system, so you can get Vim installed and all these things installed, and you can mirror that through the traditional tarball up the system environment and all that stuff, but Docker really shines very easily getting system environments set up, and no problem, Dave. And furthermore, scaling, because Docker images can be produced into containers, it's very easy to scale up and down that software. So yes, you could in other ways package your environment using traditional methods. Scaling that software once it's packaged is not necessarily as trivial, whereas Docker really trivializes that process. In my opinion, I haven't done a whole lot of the traditional packaging, but from what I have done, Docker just simplifies system level packages with, and again, the open source pulling in pre-built environments. You can access entire pre-built Jupyter Lab instances with a single command. So that's why my input.
Okay, great. Thank you. Yeah, David noted that he removed 35 gigabytes by running that Docker system prune. So already having an impact.
Great.